On these two questions, we want to find the domain of the radical function. Well, what we've learned is that if we have an even index, like a square root or a fourth root, sixth root, and so on, then these types of radical functions do have restrictions in the domain. And the domain is that they have to be greater than or equal to 0. If you have an odd root, like a cubed root or fifth root or seventh root or so on, then these types of radical functions have no restrictions, and so these have a domain of all real numbers. We've even investigated the graphs of these. The graph of the square root of x, which is the basic square root function, is centered at the origin, and it increases to the right. So you can see that the domain goes from 0 to infinity, whereas the cubed root function looks something like this. And so it goes forever to the left, forever to the right, therefore it has a domain of all real numbers. So when we have something that has been transformed, what we need to do is, if it does have domain restrictions, we set the inside expression greater than or equal to 0. So question 1 is an even index, so we watch out for that. And so I take 5x minus 6 and set that expression greater than or equal to 0. We want to find out what values of x would make this work. So we solve for x. So I add 6 first. Next I'm going to divide by 5. And I get x is greater than or equal to 6/5. So this is telling me that 6/5 is the lowest number, and then anything higher than that I can plug into the function and it would work. But this is not written in interval notation yet. So what we do is, if it's greater than or equal to 6/5, the lowest number graphed would be 6/5. The highest would be positive infinity. We do brackets on 6/5 because it's equal to that end point, and we always do parentheses around infinity because infinity is not a true number. So this is the domain of question 1. Now on number 2, I notice that the index is fifth root, and so that's an odd root, or an odd index. And so that would be of the family of functions like the cubed root of x, where they have no domain restrictions. So you just automatically say the domain is all real numbers, and you have to list it as an interval from negative infinity to infinity. So on a test, what I would do for these domain questions is I would first find the one that has the odd root and answer that one first, because you do not want to say 2x plus 3 is greater than or equal to 0 and go on, because that would be wrong since there are no domain restrictions.